So this is basically finding 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It's saying how many times it split. That means the moment it hit this, it will split. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. This one doesn't hit 21. So that means if we hit any splitter, we give a count of 1. So let's do that. So we do oh wait, basically we can add, okay, we do a split the count equals 0, visited splitter count equal to, oh, so actually, right, we can just add a visited set, visited splitter. Let's do visited equal a set. So once we go here, we basically saying, okay, visited dot add yx. So if it is in visited, we basically continue, right? Because we don't want to duplicate processing. So now, okay, we don't need, so make sure, do we have comment on for now because we don't need anything, but in case it need for part 2, then we might have to. Okay, so now we just need to do intersection this with our splitter set right here, which should be good. Return len of, how does Python do Python set intersection? Okay, turn splitter intersection with visited, right? So that will be that. Okay, so now we do file name expected return actual equal set restricted, but God. Right. Okay. So let's test them out. Say expect 21 here. Okay. Python day 7. 27. Oh, we got 22. What did we do wrong? Oh, we have to do the differences, right? So, what does differences? Okay, so basically we want the list of visited that is uh list of visited that is the splitter, right? So that means we have to, one way we can do that if we loop to visited and filter it in the um yeah, so let's do that. So for yx for yx in visited if yx actually in the visitor no splitter. Right, that's it, I think. Still 20 to 21, guys. So basically we count the number of visited visitor. I don't think it visited this one, right? So let's print out the visited, that is visited splitters equal to this. Right, so we print this. So we have, what's going on here? Okay, 14 0 1 2 3 4 5 6 7 8 9. 49 shouldn't exist here. So do we have 49? The question. No, we do not. What? So what do we do wrong here? Uh, so visited splitter and splitter also print out the length. Length of splitter. Length of splitter. Something like that. 22, both 22. Wow. How does it visited? Fourteen one. 14 1. So alright, let's fact check this, right? So let's also make a variable here, splitter count. Right, so if it visited to a splitter, and we count that, right? So we do a print of splitter count is right. 22. What? So we start here, and the next one we visit is this, right? So if the position we are on is splitter, we plus 1, and because it is the splitter, we split into -1 and +1, right? Okay. So yeah, if it is not splitter, in this case like these two, we look up in the y-axis. No, in the vertical, right? We found these two that is greater than these. We add them to the queue, right? Right. So and after we finish enumerate the next move, we added y-axis, right? So what is going on? Let's just add a, just call debug rate, right? Every time, right? So we also get visited. What did we do wrong here? So basically we go left all the time, then we go right. So let's just print out the y-axis and see. visited, and then visited, right? Whoa, whoa. Hmm. So we start here. Our next position will be 0, 2, and whatever this is, 2, 7. Hmm. Visited 0, 7, good. And 2, 7, yeah. So 2, 6, 4, 6, and 3. Oh, maybe here, right? So we do this, and we should just take the first one, right? Because we don't want to add all the thing here, right? So this should be it. From the beginning to 1, right? Because let's say we are at this one right here, and we actually add this one where we don't even know if it's gonna, I mean, it greater than for sure. No, this one, right? Hold on. Yeah, we actually add this one and this one, right? Okay. So basically, yeah. So let's see. That's the case. Okay. So basically, we can do this. Yep. So that is correct. 21. Visit the splitter is 21. Yep. So we can do this, right? And then we comment the cell. Yep. So yep. So let's see. No, the cells. Where does it print? Oh, right. There we go. So now, if we do let's add a git ignore. Uh, we'll get the git ignore next later. We'll try to submit this first. Okay, this is the number. Yep. So, yep. Uh, what are they even saying here? Bring up the text here. Check social media real quick for part two. Let's just copy the part two here. We'll read after. So it seems like we want to count the number of paths from here um, to the out of this. So we always left and right, right? So let's see. So it sounds to me like we need to keep track of the path, like the position when it get here, right? So let's say you go all the way here. That's one. So the path from this is like one here, right? But then when it go here is plus one again. So two, 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 right? So it go here again. Then it will also split two here, right? So that will be one. So like three, 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 right? And do it again, right? So that will be two, but four, 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 right? And so on. And because we do depth first search, we should be able to see all these, right? And then like once we sum all this stuff to the thing here, we just need to do that, right? I'll put the value here, right? So let me check here. Okay, so let's try that. That means we need to add a third here. Maybe like instead of that, we add a path here, right? This will be the path from the root to the current node. Right, so here we have to do this yx, right? And then this is also path plus like yx, right? So now we know the path from whatever we start from to the end here, right? So this will be, so hold on, let me take off the text here, right? So once we know, like we get out of this, right? So that means we have to loop to the parent, right? So let's call this y parent x parent in the path, and we need a way to store the path count per node, because if we visited them again, like for example here, right? Go here and what yeah, so like that. So let's call this, what do we call this, path count, right? So in any particular node we want to find the number a path is gonna spin off of. So let's call this path count, right? So we go here, let's say we ended up here, right? So then here, then we have to say that this this and this would add it plus one, right? So that means, so we say if this is not in our path count yet, then we add the path count of yp xp, xp stand for parents, plus equal 1. And because we found the path, for the sake of completeness, we'll do y and x go 1 because we count the path. So like if we get here, oh no, get here, right? So get here, right? This would be one path count, right? So if we get here, another path count. So every time we have found the path count, we have to go up the parent to count that path for all of them, right? So this is the case where we couldn't find the next move like this one. We go here and there's no more. If we drop down, there's no more splitter in this vertical to uh to move to. So this is also another path, right? So if we couldn't find any candidate in the same move, right? Okay, so yeah. So this move is like that. So and then if the candidate splitter is empty, like if we have this non splitter and oh, so this path right here and this path right here actually the same path, the same code, right? But for the sake of um we'll refactor, right? So this is the same path. So we just we can just do a label go to here, right? But like what they taught you, go to consider harmful, right? Whatever this is. Uh, this is the Netherlands, right? So we'll do this. Oh, this is too low quality here. Uh, but in my point of view, like as long as it's not like as long as it's not confusing, it should be fine. Let's see. Let's find some of the. Oh my God! How many cookies are there? Even the ACM have cookie, guys. What is going on? Um, letter. Okay, let's quote this guy here. Whatever this is, I don't have the membership. So, um, so let's just copy the code we think about here, right? So, right. Okay, right. Okay, so now if what is this agent says in here? What the hell? Whatever. I don't care. Oh yeah. Nothing we need to do is we count the path. Then we gotta say like, what if somewhere here we found the path that like uh ended up in this path, right? So that means let's say what's the good example here? Like okay, hold on. I'm just trying to trace the thinking here. So let's say we okay right here. So if we visit this first and then we hit we enter into this splitter right here and we count them, right? So the next time when we go to this one, it's gonna hit this one again. That mean all the parent of this one will have the same path as the one that is found here. Because we have depth first search, that mean we will be able we will visit this before this, right? Because we do left and then right? So we do this, right, and then right here, and then we do right here, do left and right, and whatever, right? So that means if we come across that path, we also need to loop to the parent, right? But I think this can copy this, but this number will be different, right? So okay, so okay, if what is this? Oh, we sorry, this is the wrong one. So we should do this. Check if the variable is not in, right? So then we just put a value 0 here, right? Right. So same thing here. So so this is out here. Path count of yp xp equals 0, right? So copy it back here, right? So let's note here. So this means that we already found one visited. So that means right. So that means we have the parent has to plus equal to the path count of the y-axis, right? So because like I think because we have that first search, right? So if we visit again, this should already, yeah, we already visit this under this one, right? So if we go from here to this already have some result. So everyone from here up to the parent has to plus equal whatever the result of this, right? So yeah, and in part 2 they want to count the number of paths. Oh, sorry. So uh let's unify part 1 and part 2 here with we pass a function and then we ask return part function. All right, let's just pass this visited splitters, and for part 2 we just need to pass the path count, right? So the part 1 function will be refactor stuff. Basically we copy this, put it here, right? So visited and splitters, right? So and this is a little bit awkward because now in the part 1 doesn't even use path count. So that's fine for now, I guess. In part 2 though, we need to find out, but because we unified the function, it's gonna be awkward because we still need part 2 need to find the result, right? Because we sum all the path up until this point, right? So that means we need start x start y, right? Right. So this is basically going to be return path count of start y start x, right? Let's do, what is our convention here? Yx. So let's do start y start x, right? So this will be start y start x, right? So now it's kind of awkward that we need to pass the function here and they expect different thing. So is it possible? Oh, we also need to do go to here. I guess we also copy this uh right here, link to this. We have to refactor later on. Okay. uh but is there a way to unify part 1 and part 2 where they did not even call the same thing? So part 2 is doing, just need these, right? Part 2 only need these, only need these two, right? So hmm I guess that will do fine for now. Let's just do that. Let's just do the same thing here. The code doesn't look as nice, but that's fine. We don't even know if we did the part 2 correct. So let's see. Let's see about that first. So now this has to do call the part function, and we part this. It will be part 1 function, part 1 function. Let's confirm that it is still working first. Oh, what happened? Cannot assign to expression. What? Oh, this we have to move it here, right? So we look to that, and same for here, because we added extra path here. So we do that. Right, so let's see if part 1 still pass. Oh, what is this? Someone send me a message. I'll do that later. Okay, so right here. This is dictionary object not countable. Oh, this one has to be subscription thing. Okay, and also trim trailing. Yep, I'll do that. Okay, so this needs start y start x path count splitters, right? So oh, will be SYSX. Okay, SYSX. Do that. Okay, part 1 passed. Let's see. Okay, so sample, what did they expect? 40. So that will be 40. Okay, seems to work. Let's see what the number is. This number. This is a big number. Do that. Yes. Okay. Return to this. We got 7 done. So we got day 7 done. Yay. We commit and then part and then and part 8 soon. Oh no. Date 8 soon. Right. That. Let me do git commit. Oh wait. I actually forgot to commit parts 1. Oh my god. Oh no. Where's day 7? Git.add. Okay, fine. Just do in one commit then. Just need to remember day 7 but 1 plus 2. Just come remember to do that for part 8. Let me check 1 second. We play today, boss. Being my friend, we may be playing game at 7-ish. I don't know. I need to eat. I mean 6:30 or 6:45. I need to get off this stream. So do that. Okay, so let's read part 8 and see. Day 8 and see. What are they doing? Okay. Day 8. Will be this one. This one. Whatever they're saying here. 1 second. Let me turn off the heater. It's hot. Oh, and then before we doing that, let's look at the goto problem here. Does Python have goto? Python does not have goto. Okay, sure. Can we refactor this part right here? Right, so so does that mean we can do if x in splitter by x? Oh no, if basically if x not in splitter by x, right? What is it? Or so this one right here. We do a boolean of this. So that means not that or not candidate splitter, right? Then we'll do this. So we can do this, right? Right. Turns out Python does not have goto. Right, so we do this part right here. Right. Right. Else mean we still have to get the candidate. Right, so we can do this. Right. Okay, so if not else we do this, right? Right, so then we can remove this because this is do not repeat yourself, but yeah. DRY. So let's see if the code's still passing. Oh, what's going on here? Oh, so okay. So we need to okay, so we do this if x not in splitter by y. If it's in, else we do that. Right? Yep, still works. We'll do some refactor. Do this. And call this. Man, no, I did. Right. Okay, so day 7 is done. Look at day 8, what they even say here. Let's copy this. APC and WC, hi, what's up? Let me check Discord. And that works. Let me eat at 7 p.m. then. Or earlier. Okay, I'm just coordinating gameplay. Okay. What are you writing? Ah, I am doing Advent of Code in Python. Someone on Twitch asking. Mm, so I need to go to the bathroom, but after that we can do bathroom break, then read part 1, day 8, part 1. And let's figure out gradient opacity. What is that? Oh, this is for that. How does the text work in background color? Oh, I don't know how this step work. That's fine. Okay, let me get some water. Okay. Uh, do music is done. What are we going to do? Let's switch some music. Oh, cancel. Okay, music. Okay. Oh, Daft Punk. Look at that. Maybe we'll do Daft Punk. Hmm. Okay, so let's see what day 8 is about. Maybe move this a little bit. Okay. So you have like 3D space, XYZ. Hmm. Hi, Ducho. Who's this? Friends. Who is this? Hold on. Channel activity. How do I? Hi. What is this? Prince something. Too small for me to see. Hi. Let me type. Hi. Someone on YouTube. Oh, hi, dude. Not Ducho. Okay. Uh. Saw you alone. So yeah, I can only do a little bit after work. Then I have. I think I have gaming. Like in 1 hour or something. Thank you for stopping by. Let me also somehow subscribe you. Open link. Smoking needs skill. What? Print something. Okay, subscribe. Thank you. Stopping by. You have a lot of Cristiano Ronaldo stuff. I like it. Um, yeah, we're just looking at the his YouTube channel. Thank you for watching. I guess you don't. You only have short, but cool. Thank you. I already subscribed. If you I had my exam today. Instead studying, I saw you. Oh, well, good luck on your exam. I don't know how hard it is, but it is what it is. Okay. Keep coding. Yeah. No, like all of these, I want to solve them, and then we'll pick a language, and later on in the future, we'll ask Gemini to generate that and see if it and check if the AI is actually can one shot, right? But yeah. All right. Back to day 8. Okay, so they doing some Euclidean distance. This is 2D, right? I think you have to do square root between the point or something for the 3 dimension, right? Yeah, 2 dimension, higher dimension. Yeah, so 3 dimension, we'll have to do this. So for sure, let's just implement that, right? Distance between P and Q. Um, Be this Python. Pretty sure Python have square root, right? From math, maybe import. Yeah, will be return. We'll do a point is a triple of x, y, z, right? So we'll do square root of p square. So let's just do square, right? Put the point up a point will be, so let's do p1, p2, and p, right? So it will be p multiplied by p, right? Whatever this is. So it will be p1 0 minus p2 0, right? So we for sure need to use this function somehow, right? Square root of this, right? So plus, oh, square, right? Square, forgot the function. Plus square of p11 minus p21, right? Plus square of p12 minus p p22, right? So is this possible to loop through a tuple, right? So let's see, Python loop through tuple, right? Oh, you can do that, yes. So that means we can do return to the square root of sum for, so it will be square root no, square of for I in range, right? Length of p1, right? We would do square of p1i minus p2i, right? Something like that. What happened here? Oh, sum. So okay, hold on. Square of this. What's wrong here? Yeah, p1i, right? Right here. Okay, hold on. Confusing. So first we gotta loop with the tuple for I in range of length p1, right? Whatever, because assumption is both p1 and p2 having the same number of tuple component, whatever they call it. Right, so we do this, and this will give us, we do square of p1i minus p2i, right? And basically we gotta sum this and can do square root, right? So do that. Yep, maybe. Okay, now back to this. To save, so you need to connect pair of these, right? So you connect these and these. Is that look like we have to loop to find all the pair. We have to loop O n square. So maybe it won't take time, but we'll see. Mm. By connecting these two junctions together. So one circuit have two, okay, and the remaining 18. Okay. Uh, Let me see. Um, Now the two junction. Oof, time's running out. After 6:45 or 7 to maybe we can wrap up part one. I don't know. I don't even get to the end of the understanding of this stuff right now. After connecting them, let's do. It seemed like they want. Okay. So we somehow need to get the clothes together. Okay, so that sound like we have to sort the pairs. So let's just do a reading. Parsing the input. Find name, right? So for width, open. Find name as f, right? For line in f, right? So we'll do. I think it should be able to do this, right? Split by this, right? So let's check that. Python do x, y, z equal to. Can we do? Can we do this? Split. Oh, split by comma. X, Y, Z. Nice. Mm. Can we do even further? Like convert them into integer as well, right? Integer. Uh, yes. Ooh, nice. Okay. So we'll get the XYZ. Okay. So now let's call this point to point dot add. Okay. Let's confirm that we got the points. So cd Python. We have to put this. Oh, okay, hold on. Did we add the lock? Okay. Git remove 5 from all commit. Right. Um Ah, from before push, right? Let's also filter out before we do that, right? Let's just confirm that. Let's do now before we forgot. So um, let's confirm first that we got the value we want. Okay. Day8 sample.txt. Okay. Python. Oh, it's a pen. Ooh. Wait, this is not tuple. Maybe storing them at list is fine. Whatever. Let's just do this because I like tuple. The music is pretty good, guys. The whatever this is. Um, okay. Does that look correct? 162.817 looks good to me. Okay, so before we do that, let go continue. We want to do this. Okay, so git. Oh, let's just add the ignore here. Do we not have ignore? Hold on. Uh, touch git ignore. Where's git ignore? ls. Yeah. Um, how do we open? Okay. Vim. Oh, we do have. What is this? Oh, we do have this. So let me look at my repository. Ooh, very quiet here. What? Let me look right here. It does have this. So, oh, we didn't even push the code. Let's add it. Input file day slash txt, right? And how do we rewrite history? Git reapply, git ignore, and rewrite history, right? We don't want any file to do. Okay. Commit m at the git, right? What is it that they want me here? Uh, okay. Oh my god. So does that mean that I have to go all the way to this? For 5, ignore, okay, fine. Okay, so does remove, oh, why does it remove readme? Oh, whatever. Okay, so git status, git add. I still have the code, right? Yep. Python. Why is it deleted? What the hell? And level is add. Making sure that the deleted OCaml, okay, whatever, right? We'll remove the OCaml later because I could never get it to work. Okay, so what do we do next? Git cleanup, apply, reapply, reapply, git ignore, and remove input file from public GitHub, right? Something like that. But recommended. Okay. Let me do this, right? What? Dot, right? We're doing this. What is it doing? Is it correct? Fuck push. Wow. It's scary. Why is it removing my name stuff? Okay. Fine. Fatal. What is it doing? It's literally re-add stuff. What happened to my nim? Nim. Oh my god. What a disaster. Yeah, it re-adds stuff, right? What is it doing? There's nothing deleted, right? On branch staging. Changes to be committed. Yeah, we do have this. Okay, let's do this. Okay, whatever, right? Git commit hello new world without input file so that it is comply to uh sensitive data, right? Status branch is based on, but the upstream is gone. Uh, okay. Git status. Okay, git push, force, or whatever this is. Git push, force, tags. Okay, check my branch. What happened? Uh, okay. Or reapplying all this stuff. Okay, fine. We will see to this later. Okay, back to number 8. So basically, we have to connect the closest one by the distance. So let's generate pair first, right? So pairs equal right? um right. So for y in range of len points, right? For j in range of uh I plus 1 len. Okay, so we'll add it to the pairs append, right? So what point I equal points I. Okay. What is this? Okay. Point J points j, right? So you want to add it by this distance between them, and it will be distance between pi pj, right? And then we'll just keep a record of this pair, right? And then we'll sort them. Better sort, right? So by default, it's sorted by the first value, which is distance here. We'll print the pair here. Let me see. Oh, what is it? Oh, okay. That scared me. CD Advanced Upcode 2025. CD Python day 8. Okay. Python day 8 py a check. Oof. So first number, is that correct? It's between 162, 817, 812, and 425, 690, 689. Okay. Second one is 162, 817, 812, 431, 825, 988. Okay, good. Be 906, 360, 560, 0596, 17 looks good. Okay, so we have to loop through and connect these together. And we got to figure out a way to say, let's say these two connect, right? Like they said here, right? Because this, we got a way to say if these can it belong to the same unit, then we do nothing. So we don't put the connect here because it's already indirectly connect because they are in the same unit, right? So that means, so we need a way to quickly figure out if the 2 point need connecting if they are indirectly connected, right? So this is sound like a graph problem. So if you connect this point, right? Before you connect, you need to find like the graph that it belong to and count the number. Yeah, because you need this, right? So that sound to me like what is that? This join set, right? Wow, it's 1964. Hey. Because like, for example here, right? A node on its own will point to itself. So let's say you have these two, right? When we connect these two, right? Oh no, no, connect these two. One of them will become the root. So this will have size 2, right? Size, originally it's size 1, right? So the size of these two nodes is 1 because it's counting itself. When you connect them, one of them is should be the root, and then the size of the root, like the connectedness, is 2 because 1 2, right? So when we connect these, right, because this size 1, right, because it's alone, this is 2, so 2 is greater than this. So when we connect this, we increase it by 3, right? So this that, right? So similar here, because these belong to this group of node that has the root here, right? 425, because they connect here earlier, and this we connected earlier, right? So we find, so basically if we find the parents that are the same, then we know that they are connected. They don't have we don't have to connect them, right? Because they ask here. So 5 junction box here, right? So basically we have a couple island, right? So like we connect them, one will be the root, and then from each of the children we have to traverse all the way to the parents, so that we know if they're connected, right? Which is like exactly the idea behind this data structure right here, right? What time is it? 6:51. I think I have a game to play at 7:30. I don't know how long that will be. Maybe 10 or 11. Then we maybe be able to come back and implement this maybe. So sound like to uh we need to figure out the connected components. This is the disjoint set data structures. I will do. What is this? Who's sending me all these spam messages? Okay, so we'll add it here. So when we come back, right, we'll find out, right? And what did they say here? So basically we loop through the pair, right? For same idea here, right? So no, we just loop through them, right? So for distance, do we care about distance yet? P1 P2 in pair, right? And they say here connect together the 1,000 pair, right? So it sounds like we have to do here, right? Right. And then we do disjoint data set here, right? So we gotta say like if they are in the same unit, then do nothing, right? Right, if they are not, so if they're in the same unit, that means you need to find their parent, right? So somehow if and then eventually we want to set the node size equal to plus equal to let's call this p1 dot parent size equal to p2 dot size, right? And before we do that, we need p1 to always be the one with size greater than p2, right? That means we have to swap p1 p2 as needed, right? Okay, so we look to that, and if they are in the same unit, meaning we continue, right? So basically, if the root of this guy is the same a node, then we just continue, right? If not, then basically we pick the one with the bigger size to be the root, right? And then yeah, then basically just pass here, right? So we'll have to implement this when we get back. I don't know when. So maybe we need to have, what is it, circuits, right? Let's call it circuits, right? So after that we need to sort, right? The we have to filter circuits, right? By the root, right? Because there can be a lot of nodes, but we only care about the parent. And then take the three biggest size, right? And that's how we return. So we'll have to implement this when we get back. I don't know when though. So I'm gonna have to go eat dinner now. So let's call it a day for advent upcode. Today I'll go eat dinner. I'll play some games with friends, and maybe it can be back. But bye for now.